All right, great. Well, good morning, everyone, and thank you very much for choosing this session. I appreciate that English is not the first language for many of you, so I'll try my best to keep it at a reasonable pace in terms of how I speak, and I hope it's clear for you. And I know that this conference has been running for several days already, and this is the last day. The last day always tends to be tough, especially for presenters, because most people disappear, People have got flights to catch, they've got to get back to work, they want to go home. By the third day, your brain is full and you're kind of too much information, you just want to get out. So I kind of feel privileged that at least I'm in the morning. It's a shame that I didn't have time to attend the rest of the conference because I came from Tunisia just yesterday, where there was the WTIS 17 conference in Hammamet. This is from the United Nations, so they are talking about the use of big data, for example, in a lot of applications, telecommunications applications, and I was asked to participate in this panel. It was a wonderful experience. First time I'd been to a UN-organized event, and you've got these translators sitting in their booths at the back, Russian, Spanish, French, Arabic, English, and so the room was packed, it's an enormous room, and it's wonderful. You see all these little nameplates for countries, Zimbabwe, Kazakhstan, Russia, China, and it's wonderful. It's like being it's a kind of mini UN kind of meeting. Just a few slides about myself, and I know time is always tight for these things, and one speaker tends to kind of present too much and go over, but I'm on a tight schedule as well, so sadly I have to leave straight after here to go to Madrid for the next meeting. So this week has been sleeping in hotel rooms all week, so I'm kind of a little bit jaded. Okay, so let me just a few slides about myself. Okay, so who I am and what I do. Okay, so I am Akmal Chaudhri, and so my background, I'm an old guy. I mean, basically that's what it says. Okay, so as you can see, grey hair, white hair, no hair. I've been in IT a long time, too long to kind of mention. So I've done a bit of everything. So I've been involved as a developer. I've been an academic, a researcher. I've worked for technical marketing, and I've had the opportunity to work for some large organizations, IBM, for example. And I've worked in the big data space as well. So a few years ago, I was with Hortonworks, and then subsequently worked for a few startup companies as well. So today I work for a company called GridGain. So GridGain are based in Foster City, California. And GridGain originally started out developing something called an in-memory data grid, IMDG. Okay, so there are some commercial products out there as well, such as Hazelcast. Maybe you've heard of it. Oracle Coherence is another example. And so they open sourced their technology to the Apache Software Foundation a few years ago. And at Apache, it's called Apache Ignite. Okay? So this is the kind of standard model for a lot of startups today. Basically, give your software away for free, and then you charge for some enterprise features, training, services, bug fixes for enterprise applications, and that's the way that GridGain works as well. So that's what we'll focus on today, but only the open source technology. Okay, so I've done lots of stuff. Okay, basically all that says. So, many different roles that I've held, but a lot of effort and time spent doing kind of developer relations types activities. So working with developers, universities, and helping to try to not so much evangelize, although that's my kind of title, but really help promote and raise awareness of technologies. I've worked on a couple of publishing projects as well, and these make wonderful gifts for family, friends, anyone, any time of year you're thinking of, you can buy one of these and give them. I get a royalty check for $25. Well, I used to get a royalty check for $25 every 6 months. I don't get that anymore. These are old things. Look, object-oriented databases, XML databases. Who uses them today? Nobody. That's the way it is. Technology comes and goes, that's the way things are. Years ago when I started in IT, it was the case, I think, that you could be doing something for a few years and the outside world didn't change very much. Things kind of moved at a steady pace. Today, 6 months is too long. 3 months is too long. New things are coming along all the time, and there's great stuff coming through the open source communities, and technologies such as Spark and all these kind of things are really gaining a lot of traction. Specifically for Ignite, then if you do a search on my name on Dzone, there's a series of articles that I published on Apache Ignite, because when GridGain hired me, I didn't know anything about the product. Part of the reason they hired me because I knew nothing. Okay? I came with no baggage, no preconceptions, so I had to learn about this as well. And so over time, they got me to write some articles about what I learned, what did I learn this week. So I wrote it down, published it. So if you search on Dzone, and those articles have been syndicated a few other places as well. So this is a big community, okay? So they're based in Southeast Asia. So my articles have sort of popped up there as well. But as I said, Dzone is a great place, as you know, great for a lot of free content, tutorials, articles. And so you'll find the content there. Okay, so enough about me. And let's switch to the main presentation. Okay, so this is really talking about a couple of technologies. So we'll mention Ignite quite a lot, okay? Because I think you're probably fairly familiar with Spark, all right? Everybody knows about Spark, and it's very, very popular. Just a few weeks ago, they had the Spark Summit Europe in Dublin. Phenomenal interest, 1,200, 1,500 people attending, great event. And the quality of the presentation is also very, very high in terms of what people are doing with open source technologies and Spark in particular. So I'm on Twitter, okay, and I'm on LinkedIn, Facebook as well, so if you want to reach out on social media, please feel free to connect with me, and there is the GridGain website where you can find further information. Okay, so in terms of agenda then, what I'd like to do is talk a little bit about some of the demands for IoT, Internet of Things. What are the sorts of things that we are kind of interested in? And then discuss a specific stack based entirely on Apache Software Foundation technologies. Okay, so this is all free, 100% open source that you can use to build this type of environment. At the end, there is a very short demo, okay, and the code for the demo is on GitHub as well, and I'll show you where you can download that and try it out for yourself if you're interested. Okay, so it's very, very basic, but the thing is that you can use the code and you can build upon it, and you can extend it and expand it, but it's a working model. It's something that's usable today, although it's very, very basic and very simple. It shows you what's possible. Okay, so in terms of IoT then, well, Internet of Things is the kind of thing that people always, is very much in discussion today. Lots of people are talking about this. What's the sorts of things that we might want to do? Well, real-time processing is kind of important, okay? There's an example of an article a few years ago I wrote for O'Reilly, which talked about, how you've got, say, miners, they're working in mines deep underground, and we would be very interested to keep track of them, their respiration, their heart rate, these kind of things, vital signs. If something goes wrong, say there's a gas leak or something catastrophic happens, these vital signs will change very quickly. We need to act. So we need that data very, very fast, in real time, okay? Now, of course, real time can mean different things for different people, but essentially what we mean is that we want it ASAP, as quickly as possible, sub-second type of responses, so that we could act upon and make business decisions very, very quickly. So there's a kind of an extreme example. Other things, SQL, probably most of you are familiar with structured query language, and you've used it with relational technology, and this is still, the lingua franca. It is the intergalactic data speak today. So whether you like it or you hate it, unfortunately, you still have to use it, okay? And the thing is that it's very, very capable. As a language, it's very mature, it's well understood, it's well supported by all the major commercial vendors, you know, Oracle, Microsoft, IBM, but equally, you might be using MySQL or Postgres, for example. You know, these are great open source tools that support SQL. So we want to be able to do querying. And we might need things like geospatial support as well. You know, for the mine case is a good one where we want to be able to locate people very, very fast to know exactly where they are so we can direct our energy and resources into finding them if we need to act quickly. Analytics, okay, so business intelligence, and of course everybody's adding machine learning libraries today. You know, you've probably heard enough of, you know, this vendor supporting machine learning, that vendor supporting machine learning. Well, I'm happy to tell you that Ignite also supports machine learning, okay, so they've got this work in progress of these capabilities. So none of these kind of things are very new. So, you know, the data science and the machine learning is something that people talk a lot about today. But if you think about it, these are actually techniques and ideas and algorithms that are quite old, right? It's just that today we have the processing power and the tools to be able to do useful things with this. So if you look at Spark, for example, it's a great way to do an enormous amount of number crunching over large amounts of data. And especially with things like machine learning algorithms where you might want to iterate repeatedly, you know, over some data, you've got some models that you want to test, and you've got that power now to do that. This is really great, okay? So these capabilities are kind of very useful in today's world. High availability, okay, so we want things to be able to run, and if things break down, we want some degree of recoverability, we want to have some redundancy, we want to have the ability for the, you know, the system to be able to heal itself and keep working, right? This is quite important today. And simple scalability, as the ability to scale is, I think, very, very important today. So a lot of the tools and technologies that you see today, they talk about this kind of, you know, horizontal scalability, you know, the ability to just add new machines, build your cluster up, use that processing power, and if you find that some of those resources are no longer required, just remove them, okay? So this is very, very useful. So the kind of proposed stack for IoT type of applications looks a little bit like this, okay? So at the bottom level, we've got device, real-time operating system, then we've got data collection and enrichment, okay? And then HTAP, okay? So this is kind of hybrid, both online analytical processing and online transaction processing, both capabilities that we want. And at the highest level, application APIs. Okay, so we've got different programming languages that we can use and the ability to work with these underlying technologies in a useful way. And specifically, if we map this down to Apache Software Foundation tools and technologies, then we can see that there's a very good kind of mapping here. Okay, so at the lowest level, we've got something called Newt. Okay, very, very tight, very small type of operating system, can run in constrained environments, very useful for devices, you know, things like wearables, for example, you know, everybody's got one of these Fitbit type things. Those kind of environments, you want something that really can run in this type of environment. And then for data collection, then we are spoiled for choice, okay? Lots of tools available, Spark streaming, for example, Kafka, queuing, you know, Apache Flink. There are many, many choices that we have available. For HTAP, then we're proposing something like Ignite. That could be very useful, okay? So it's specifically designed for both online analytical processing and online transaction processing. And then at the highest level, in terms of how do we interact with these lower levels, well, we've got a couple of choices. Again, Ignite has a number of APIs. It works with Java, C#, C++, and then of course it has things like JDBC and ODBC support, so if you want to work with things like Python or other languages, you can do that as well, it's not a problem. And Spark Streaming, of course, is again a great sort of choice in terms of streaming technology that can work very effectively. Okay, so quickly then, just from the lowest level, let's kind of drill upwards and see what these types of things, you know, how they could be used. So you'll notice that, you know, the spelling minute, if in English you say that fast enough, you say minute, okay? Minute means small, okay? That's the kind of slight play on words there. But this is a very, very interesting kind of project. It's an open source, real-time operating system, okay? Very tight, Cortex-M MIPS, okay? Really designed to run in constrained environments, okay? Typically for things like wearables and some types of these devices that we might have, well, you might want sort of low power. You know, things like Bluetooth will be sufficient. But equally, you might want support for things like TCP/IP, UDP, those kind of things, because Bluetooth has only a certain range, and it can only communicate within that range. If you've got things further away, then it's a little bit difficult. You need other support as well. So that is something that's built in as well. A secure bootloader, because when we are running this type of thing in an environment, then we need to be sure that everything is as it should be, that it's not being interfered with, it is not being manipulated or hacked into somehow, and that's quite important to be able to run these devices, particularly when we're doing it on these kind of personal devices, okay, where we may be storing some information about people. And finally, remote firmware upgrade as well, because these things going to be running far away. We need some capability to be able to upgrade the software over time as bug fixes and new improvements take place, then that's quite important. Okay, so moving up a level then, let's look at things like data collection and enrichment then. Okay, so Spark streaming could be a very good sort of solution in this space. Okay, there was a few others that we mentioned in the previous slide. Sometimes people ask the question, they say, well look, I'm using Apache Flink, for example, for a lot of my streaming capability. Why would I be interested in Ignite? Why would I be interested in Spark? And the answer is very difficult. It's a tough question, very hard to answer, because one of the issues, of course, is that a lot of these Apache Software Foundation projects, there is overlap between them. I mean, it's happened over time. And so it's kind of tough. You're looking at this technology and you're looking at that technology and you're saying, well, look, they kind of do the same thing, or there's a big overlap between them. How do I choose which one to use? And I think my kind of observation on this is that if you are working with a particular ASF technology, it happens to meet your requirements and you're happy with it, overall in terms of how its capabilities and the business benefits it brings to you, stick with it. Don't think about moving to something else just because it's the latest and greatest, or the next big thing, or it's the hottest thing available. The key thing here is to use something that meets your requirements. It's good for your business use cases, and if it's a well-supported project, as many of these ASF projects are, then the best thing to do is stay with that and look for other capabilities that are kind of complementary, other technologies that will help you in different areas. So that's the key thing there. So Spark streaming, good sort of case in point. And then we could use something like an Apache Ignite cluster. Okay, so Ignite comes from the in-memory data grid environment. So effectively think of it as a technology that allows you to cache data in memory. You can grow your cluster, okay, as you need more processing power, as you need more sort of capability, and it will utilize those resources to be able to distribute your data, okay? And you can process these at memory speeds. Now, it's got some other nice features as well. So what they've done is they've added the ability to save the data to disk as well. Persistence, okay? This is very useful because in the event there's something catastrophic happens, your entire cluster goes down, all your data is lost, okay? But if you've added some persistence, the ability to write to disk as well, then that state can be saved. You bring your cluster up, you can do so very, very quickly because it can read what was the state of the data at some point in time, okay? So we can use the Spark streaming, we can stream that data into Ignite. Ignite can then do additional processing for us, okay? Which is the kind of the next level up which we'll look at. So very briefly, as the Americans say, this is the kind of 50,000-foot view or 30,000-foot view of what Ignite is. So at its lowest level, really, it's a memory-centric storage architecture. It's very efficient at using memory and the ability to add additional sort of cluster resources, and it will be able to distribute your data in the cluster, okay? Think of it as a distributed hash map. That's all it is, okay? So there is a key value that it uses. It applies an algorithm to the key. It finds where it needs to store that data in the cluster, and it will store the primary copy of the data on that particular machine in the cluster. You can configure it to have backup copies as well, okay? It's a peer-to-peer architecture. There is no master-slave. It's entirely, all nodes are equal, okay? And what it will do is allow you to really utilize memory very, very efficiently. We talked about the persistence capability. So natively, it supports persistence. Again, this is very useful for certain types of processing. And if we're dealing with large amounts of sort of sensor data or sort of personal data, and we want to process that very fast and want to store that for sort of future reference, we can do that. Equally, it can also plug in to third-party systems. So if you're using MySQL or Postgres, for example, that's fine. Use those as well. Okay, that's perfectly capable. You may be working with HDFS, for example. That's okay too. Or perhaps some new SQL product. That's all right too. I mean, those are third-party sort of plugins, adapters that are supported as well. On top of this memory-centric storage, then there's a couple of capabilities. So historically, where this technology came from, key value. Okay. Now, you are maybe familiar with other key value products out there. Redis, for example, is a very good, very fast key value store as well. So this is something that's been supported with Ignite excuse me, for a long time. The thing is, Ignite does transactions as well. Okay? Atomic units of work. It supports SQL. Okay? This is a recent addition. It's SQL 99. Okay? Yes, question?
These transactions, are they guaranteed across all the nodes?
They are, yes. And I know what your next question is going to be. If it's a distributed environment, how can you ensure, because in a distributed environment, you end up with a situation of latency, hardware issues. It's configurable. So you can decide upon how rigorous you want that. You want full ACID transaction to say everything gets done or nothing gets done, and it's the same across the entire cluster. Or you can relax those conditions a little bit to say, okay, in the event that there's a delay, I can roll back my transaction, or there's some other action that I can take. But that's a great question, and it's one that often gets asked. Thank you very much for raising that. Other things, streaming. So, as I said before, we're spoiled for choice for streaming technologies. Apache Flink, Spark streaming. Well, Ignite supports adapters for all of these streaming engines as well. And it does machine learning, like everybody else. Okay, everybody wants to do machine learning. We do it too. Okay, so the Ignite supports that, and then of course, right at the top level, lots of different verticals and examples. So if you look on the Apache website, okay, so ignite.apache.org, they'll give you plenty of examples of commercial organizations in many of these verticals using this technology for real systems and real applications. Very briefly, then look at a couple of other sort of things around this that we could, and then we'll discuss a specific kind of use case from the IoT space. Oh, and by the way, don't worry too much. I mean, the slides will be all available as well. Okay, so if you're busy kind of taking pictures, you're very welcome to do so. I'm very happy for you, but the slides will be available anyway. Okay, so no problems there. So one of the other things that Ignite supports is this notion of a data grid. Okay, so this is also known as key value store. Okay, which I previously mentioned. And for those of you who are familiar with Java and you've worked in the Java space, then it uses industry standards such as JCache, for example. Okay, so that's well and good. The transactions we briefly touched on previously. The SQL support we talked about. The compute we'll get onto in just a moment. Okay. So, as I mentioned, what Ignite does, it treats things as a distributed partitioned hash map, okay? So, unlike some other cluster computing systems out there, and Cassandra is a good example where it's very kind of gossipy, it does a lot of communication between the various nodes to find out where data are. Ignite knows straight away. So when you issue a query and you want to know where some data are, it knows straight away where that data are located, okay? We talked about the durable memory, okay, the ability to write the disk, and the scalability. This is where it really achieves it. So as you need more power, just add more nodes. It's as simple as that. And this thing will run anywhere, okay? So it will run on a laptop, it will run in Kubernetes, it will run on Amazon Web Services, Azure. It can be hybrid cloud, or it can be private cloud or public cloud, wherever, okay? So as long as it's configured correctly. So a little bit later when I show you the demo, you'll see that it's running on my laptop quite happily, okay? So you can configure the amount of memory and resources that it needs, but that's very, very easy to do. The ACID transactions, which kind of touched upon a while back. The distributed SQL, okay, so again, some important points related to this. Remember, this is one of the things that we kind of mentioned early on. Could be very useful to us in a sort of an IoT type of application in terms of how we process the data. Partly the reason is that SQL is widely used. There's a great skill set out there already. Lots and lots of tools work with it, and then this is the good reason to use it, rather than just inventing something totally new. Why? You know, because the industry has kind of moved around this. Now, I appreciate that SQL has dialects, okay? So if you're using one vendor's version of SQL versus another vendor's version of SQL, okay, you know, there are differences between them. That tends to happen. But overall, the thing is that they tend to do the same thing, okay? And if you've learned it sufficiently, then it tends to be, you know, pretty good in terms of cross-platform capability. Okay, so as I mentioned before, because Ignite is written in Java, obviously Java 100% support, okay? But if you're a .NET user or you're a C++ user, equally well supported as well. And then other languages such as, you know, maybe you want to do sort of dashboards, or you want to do some business intelligence, Tableau or some other sort of popular tools like that, you can plug those in, no problem, because it's got JDBC, ODBC support as well. No problem there. Okay, very easy to do that. Anything else worth mentioning here? Oh yes, the dynamic scaling we talked about, indexes in RAM or disk. Again, a key point here is that all of the data are stored on disk. Some of the data are cached, okay? And as you're issuing queries and it's hitting memory and it's unable to find that data, it'll just go to disk, pull up that data for you, okay? This is for large amounts of data that you've decided you want to persist on disk. Yes, question?
When you say dynamic scaling,
yes.
Is that, do you mean the workload increases on the number of requests that need to be handled, then
yes.
you can add additional nodes that are taken, because the nodes are all equal and all contain all the data. Is
yes,
that right?
absolutely. So as you need, okay, so the point there was really, in terms of dynamic scaling, you know, the ability to elastically scale up and down as you need it, the cluster will manage that for you. So if you find that your processing is insufficient, you add more nodes to the cluster, it will realize that additional resources are available. It will be able to redistribute that data across these.
The data or the workload? Because if
you can,
all the nodes.
The data can be distributed as well, because it realizes that there's additional resources. But it's configurable. You can decide not to do that if you don't want to, but there's additional processing power available as well in terms of actually running things like queries, for example. But the thing is, because the way Ignite tends to work, there is something that's in a later slide, but I'll just briefly mention it now. It's this idea of co-location, which is very useful. So on a node, for example, you might say, let me give you a good example. So you might say, okay, I've got a company and all the employees that work for that company. I'm going to co-locate these together on one particular node, because I know that most of my queries that I run are related to that company and the employees that work for it. So rather than having to sort of issue that query across the entire cluster where all the data may be distributed, all the employees may be sort of spread out, I know that this is a good sort of architectural decision, because many of my queries then can just run on one node. I'll get the results back quickly. And again, there are other kind of useful applications for this. So think about the hurricane that hit New York some years ago. So if I am the US sort of weather service and I want to warn people that, you know, be careful, there's a hurricane on its way, you know, take appropriate action, then that's very easy to do, because I can associate all the people that live in New York with New York, store it on one particular node. I only have to hit that one node in terms of the queries. The node can then issue the SMS messages out for me, and then that's very great, because again, it limits the amount of work that my cluster has to do. It knows that that's the sort of query I want to run. So there's some useful sort of cases in terms of both the processing and the data as well. Okay. Quickly, let's couple of other things then. So compute grid. So this is something that many of you may be familiar with if you know about MapReduce, for example. So the idea is basically, as stuff comes in, you want to do some work, that gets broken down, it realizes, you know, what sort of resources are available, it's able to split that work, parallelize it. Those cluster nodes then will return the result, you combine it, and you send it back, okay? So for many of you who've worked with MapReduce or fork join, as this is called, okay, this should be very, very familiar. In theory, you know, here we've got two cluster nodes, so the idea is that you get the result in half the time. I mean, that's an ideal kind of situation. In reality, of course, it may vary. The thing is that what you can do then is, again, utilize the resources that you have available in terms of breaking the work down and being able to parallelize it and have the results sort of return to you and be able to combine them, send them back to the client as you need it. Okay, so a couple of useful things there. Again, great for, again, in terms of speed and scale. Okay, so these are the two things that you really get sort of benefit from here. Okay, so a little bit on Spark then. So one of the things that Ignite supports is this notion of this in-memory shared RDD. Okay. Those of you who work with Spark, you'll know that Databricks and others keep telling us now, don't use RDDs anymore, okay? Everything is kind of data frames and data sets, right? So data frame support is on the way. The thing is, what this provides you is the ability to work with Spark. This shared RDD is just a wrapper around an Ignite cache, okay? So think of an Ignite cache a little bit like a kind of collection or a relational table. That's all it is. It's just a way to store data, but we're doing so in memory, okay? And with the persistence capabilities I talked about, I mean, ignore that just for the moment, okay? Just for the sake of the discussion. So essentially what this thing is, it allows you to share the state of data as far as Spark is concerned. So the presentation, for example, that I did at Spark Summit in Dublin, I showed an example of where we can use this kind of shared RDD. So I've got a Spark master running, I've got a worker running, I launch an application to store some data in an RDD, okay, and then another application to retrieve that data, but then I kill my Spark master, I kill my worker, they're gone, okay? But the thing is that because I'm using an Ignite cache to store this data, the data is still there. I can launch another Spark master, another worker, connect to this Ignite cache, be able to read that data in. So it's a great way to be able to share data across different Spark applications, okay? So you've got Spark workers, Spark jobs, and this notion of a kind of in-memory structure that's very useful. So RDD support is already there, data frame support, very close, okay? It's already, because, as you know, it's an open source project, you can sign up to the developer list, you can see the work that's in progress, there's early releases out there as well, you can try it for yourselves and see how this really works, okay? So other things as well, I talked about HDFS support, but if you're working with things like Mesos, Docker, Yarn, those kind of things, there's integration with those technologies as well, okay? So this is something to think about. Okay, let me keep an eye on the time, okay? Because I don't want to overrun. Right. All right, so as I said before, everybody's doing machine learning, okay? Go to any vendor, they'll tell you they've got a machine learning library now, okay? So this is the nice thing about industry kind of trends and movements. So Ignite supports some capabilities in this space as well. So there is an early release, okay, it's still in beta, okay? So it's not fully baked, as they say, but there is at the moment support for things like sparse and dense matrix algebra, k-means clustering, regressions, decision trees, random forest, all these type of things are in the works. I think the key benefit here to note about this, because everyone does machine learning, but how do you apply these techniques to distributed processing? It's a tough problem, quite a challenge. As you know, distributed computing is a big problem in itself in terms of guaranteeing data and views and consistency across your machines and the kind of sacrifices that you might have to make. Okay, simply because of the nature of distributed systems, it's very difficult to know that all of the data everywhere are the same. So what they're doing is building these libraries to support these capabilities in a distributed environment. Okay. One of the questions I was asked at a previous presentation I did was, can I use stuff that I've already got? If I'm working with scikit-learn or other stuff like that, there's other types of libraries that I might have. Will these work here? They will. But the thing is, Ignite can't look inside them to see what the implementation is. It's just a black box. So you can certainly run those on a single node, but if you want to do distributed processing here, you'll have to use the libraries that they provide for the distributed processing. Okay, so keep your eyes on that. Obviously C++, Java are very well supported, but if you're working with other languages, maybe you're an R user or you're a Python user, I think even MATLAB support is in the works. And then longer term, things like deep learning, TensorFlow support, that's coming as well, okay? So these could be very, very useful for certain applications, all right? Co-located processing, okay, we touched upon that just a few moments ago. I mentioned a couple of examples of where that would be useful. And these are all use cases of companies in sort of various vertical markets using this technology. Okay, you can have a look at this from the Ignite website. A specific use case where it says large IoT provider, actually there was a name there once upon a time, very, very recently, and then my manager said we have to remove it. Apparently the customer didn't like them being mentioned in the slide presentation. It happens, I mean, what can you do? So, on the right-hand side, you can see the kind of architecture at a high level that they use. Okay, so it's about smart meters, okay? My mother's getting one fitted in her home in a couple of weeks' time. So these kind of things are great because it means you don't have to send the data, you don't do the reading, you don't have to go on the website, fill it. Well, in my case, I do it for my mum, okay? Because she's a little bit old and needs some help. So I used to get her to read the meters, send the data to me. I go onto the website, the utility provider's website, and I'd send the entries for her. Now she'll get these kind of smart meters which will be able to log this sort of energy usage for her, be able to send the data automatically to the utility company. So, you know, in this kind of scenario, you can imagine there's quite a bit of data that's being generated, you know, by lots and lots of different households. So here, in terms of the platform itself, okay, so lots of Ignite nodes, and again, the ability to just scale up and down as you need, adding more nodes, and then taking advantage of some of those capabilities that we mentioned, SQL support, transactions, compute, you know, the ability to parallelize operations, and then at the lowest level, using some, and then you see grid gain mentioned there, okay, now I apologize, okay, so there's a few kind of commercial things that they used. Grid gain needs to make money somehow, okay, they got to pay my salary and other things, so they charged for a few kind of enterprise features which they haven't open sourced, the rest is still available, so there's a few advanced things that they had to get specifically from grid gain in order to meet their requirements. So what this company does then, it develops IoT solutions, transmits energy consumption data between meters, consumers, and utilities in real time, okay? So this is a kind of a modern application, very useful one. And in the UK, we've had a number of these initiatives for a while. I'm sure in many of your countries there are either this is underway already or maybe quite well advanced as well. So the problem is, could not meet latency and throughput SLAs, okay? So this is quite demanding and quite challenging in terms of what they were trying to achieve. Existing technology infrastructure that they had wasn't really able to cope. They needed something better. So they were missing scalability and elasticity. So again, scale is, you know, you can measure it in a number of different ways. So one of them is just simply having more resources, more compute power available. And the other is that, you know, you can just add these as you need them and remove them as you don't need them. It's the same thing if you look at things like Amazon Web Services or Azure or, you know, Google Cloud. So there you pay for what you need. And then as you know, there's resources that you don't need, just you remove them, okay? So it's the same kind of principle that's being applied here. So the solution then, 50 million meter streams the data back in real time, so it's quite a lot, okay? So imagine that if we've got sort of 50 million households, that's quite a large number of sort of meters that we're doing. Co-located in-memory processing, okay, because perhaps they want to aggregate some type of data, maybe they want to be interested in certain sort of patterns of energy usage, you know, which cities are you consuming the most power, for example. Certain times a day, for example, could be very interesting. Or when certain major events happen, like, you know, weather problems, for example, or outages, or perhaps things like the World Cup, you know, everybody at halftime goes off, makes a cup of tea that generates a huge amount of electric sort of demand. These kind of things are very, very useful to analyze and be able to predict and to sort of prepare for in real time. And then advanced security and multi-tenancy. So security, again, quite important, okay? You want to protect that user's data. Now, I appreciate that sometimes you know, these smart meters, I don't know enough of the detail about this particular project to say what kind of additional information may be sent as part of that, whether there's some user-specific information or not. Okay, but we need to be careful in terms of protecting privacy, protecting data, protecting you know, the identity of the people that where those smart meters may originate. Okay, so there's some things that we have to be aware of. Okay, so I have enough time for a very, very quick demo. Let me just end here, okay? So as I said before, let's just have a look here. Oh, and before I go any further, let me just get you the link to where you can get this code from. So my boss is Dennis Magda. Okay, so Dennis is the PMC for Apache Ignite at the Apache Software Foundation, okay? So let me just have a look. Here we go. Ignite Spark IoT, okay? And if I just zoom in a little bit, no, I can't do it. Doesn't this HDMI is kind of not letting me zoom in specifically into the thing, but essentially it's just github.com/dmagda, D-M-A-G-D-A, okay, Dennis Magda, and then that will get you to his homepage. You can just see the link to this particular code download is straight from the homepage. By the way, I was pleased to see that this HDMI was working here. Just yesterday, I was at the United Nations WTIS 17 workshop in Hammamet, and I wanted to show some wonderful demos that I'd spent ages developing. We tried the HDMI, it was awful, it didn't work. I mean, there you go, you know. Somebody once said, you know, the wonderful thing about standards is there's so many of them, and HDMI is meant to be a standard, and it's supposed to be easily just plug and play, and you're supposed to just, you know, connect the cable and everything works. In reality, it doesn't, you know, not always, okay, so you have to be prepared. So that's where the code is, okay, where you can download it. I've got this loaded up in an IDE here, and again, my apologies, let's see if we can expand this. Okay, no, my keys to make the screen bigger are not working here, so again, my apologies for that, but let me just show you. So I'll talk you through what I'm going to do then. So what I'm going to do, okay, so as part of this code distribution, I've got 3 bits of Java code, okay? One of them just starts up an Ignite node, all right? And I can launch this as many times as I want, you know, 2, 3, 4, 5 if I want. It will just launch an Ignite node each time that I run it, and these nodes will find each other, okay? Because there's a configuration file that they use. So essentially, I could form a cluster of machines on my laptop, and they will be able to work in a distributed fashion as much as is possible within you know, a single machine like this. But remember what I told you earlier? I mean, Ignite will work anyway. It'll run on a laptop, it'll run in Kubernetes, Docker, you know, Amazon Web Services, wherever you want it to run. You just configure it and set it up properly, it'll be fine. I've got a simple sensor generator. Okay, so this could be something like perhaps a wearable device, you know, that's sending in sort of streams of data, and it's streaming it on a particular socket, all right? My Spark streamer setup then, what it is, I've got Spark running, and I've got Ignite doing some additional processing for me with SQL statements, okay? So it's taking that stream data, doing a bit of SQL, formatting it, and then we're getting some result out in a tabular fashion. Very, very simple, okay? But very useful, okay? Because it's summarizing the data for me and giving me like the top 20 or whatever results, and so that's what I might be interested in. And the thing is that the code is designed to kind of loop forever. It'll just keep going on and on and on as long as I want to, and don't kill the processes. So the key thing here is that typically for stream data, that's the scenario that we have. You know, it's data that's continuous. It's coming in all the time. And with this type of application, what we want to do then is typically we might say, okay, I'm interested in the last 5 minutes of data, or I'm interested in the last 10 events, okay? You're not going to save all of that stream data normally, okay? To do so, you're either going to run out of memory, or you've got to figure out some other mechanism to be able to persist that data or do something with it, okay? So typically, you'll get a batch of data in that you want to work on, like a window, okay? And then once you process that, you throw it away, and you wait for the next sort of batch of sort of 5 minutes of data or 10 events or whatever you're interested in. You process that, and then you throw that away, and then so on, okay? So it's like a window that's moving across the data in terms of time, or events, or something else that you've defined. And then what all this does then, it just manipulates that, okay? So it uses little bit of Spark streaming there. It uses Ignite processing with SQL statements just to do some summation, just to do some processing. So very, very simple application, as I said before. So let's just run that up. Now, you're going to be extremely underwhelmed by the output that two of these programs give you. So if I launch this, okay, there we go. So there's an Ignite node powering up, and again, apologies, I wanted to blow this up for you, but it's not working. So there's another thing that I need to tell my boss about HTMI. I'm complaining to him all the time about it. So all this says here, so it says Apache Ignite node is up and running, okay? And what it's saying here is servers equals 1. So at the moment, I've just got one node running. If I run this code again, another node will fire up. That one and this one will find each other. In each window, it will change to say servers equals 2, okay, because they're configured as servers. There could be clients as well, okay, but they'll just, and I can launch as many of these as I want, okay, but one is enough for our needs, all right, so that's fine. We've got an Ignite node running, it's waiting, it's sitting there, okay, I can write stuff to it, I can create caches, okay, remember a cache is just like a relational table or a collection, something that I can write to, and at the moment, all this is configured to do is just hold that data in memory. So if I kill this, I've lost everything, okay? But that's just for this particular scenario. For the sensor generator then, and again, I'll show you the code in a moment, okay? So let me launch this one now. So all this does, as I said, you're going to be underwhelmed, okay? So all it says is sensor sample generator is up and running, okay? There's no kind of output here, but it's doing some work in the background for us, okay? It's creating some random data, pushing it out, and it's waiting for something to read on a particular socket, okay? That's all that's happening, okay? Now, at the moment, nothing's connecting to it, nothing's reading it, nothing's going on. So essentially, this data is just vanishing into thin air, okay? It's just going there. Nobody is there to listen for the moment, all right? And then finally, if I start up my Spark streamer, and if I run this, then this is where we start to see something useful happening. Okay, so you see a fair bit of information and warning messages here, but that's fine. That's just log4j sort of errors and warnings. So it says Spark Streamer is up and running. Shared RDDs are instantiated. Okay, remember we talked about RDDs and this kind of wrapper that is built around a Spark, Ignite cache. And there we go. So what the code is doing then is it's taking that data, the sensor data that's coming in, the random data that's coming in, it's giving me sensor ID and count, okay? So it's doing a bit of processing using SQL, okay? In real time, and then giving me a summary of the top 20 rows here each time, okay? And then it'll just keep looping forever, okay? It'll just keep going until I want it to stop. So this is a very, very simple example of how we can apply a couple of these technologies together. Okay, so we can use Spark streaming, we can use Ignite, we can use some caching, we can use SQL, okay, because SQL is doing the processing to give us this kind of tabulated result. And we can see how we can apply a couple of these technologies together in a very simple use case to show what's possible, okay? Now, you can take this and extend upon it and build upon it and do other things as well if you want. But here you can see that it's very, very easy to set this up. And let me just try and just launch this. Okay, again, apologies. It's going to be pretty small in terms of the code that's you're going to be able to read. But let me just give you a little bit of an example here. So here we've got kind of a select statement. Okay, sensor ID, count star from temperature, where temperature is greater than 70 and temperature less than 100, group by sensor ID, order by sensor ID. So it's standard SQL, SQL 99. Yes, question?
How to be sure that his will always be running? I mean, production environments. And how tools can monitor this?
Right, okay, so the question was, essentially what we've got is something that's just continuously running, but let's say we want to be able to add some additional capabilities to the monitoring and doing some other processing as well. You just extend the code, okay? And remember, you can plug in dashboards or business intelligence tools to this interface if you want. So remember, the cache is just like a table, all right? We can read from that in terms of what's happening at a particular point in time. So I could plug in a business intelligence tool into this cache I can run some queries upon that, do some nice charts, some graphs, some pie charts and other things, just to get an idea of what's actually going on. That might be more useful to my manager, for example, because he's not a programmer, so he won't be interested in what's going on here. But this is kind of low level. It's low level. It isn't really for sort of programmer level, okay? The next stage to really enhance this would be to take some type of JDBC or DBC connection, for example, plug it into some type of visual analysis or analytics tool or something like that, and be able to do that. And for the monitoring side of it, Ignite comes with a bunch of tools that you can see what's going on as well, because you might find there are certain bottlenecks, for example, or the performance is not good in one particular part of the cluster. You want to understand what's going on. So at that level, you've got monitoring tools. And remember that because this kind of runs anywhere, natively, whatever environment you're running in, whether it's Linux or Unix, there are other tools that you have available from those environments. Plus the code itself, okay? You can have a look in terms of the processing and profiling code. There's tools available in terms of profiling, give you some idea of what's actually happening if there are problems there. And thirdly, because there are other capabilities in terms of ODBC, JDBC, certainly plugging in external third-party tools is no problem at all. You can do that very, very easily. Yes, question?
GridGain has changed the name to Ignore or?
No. Okay, so great question. So the question there is... Okay, so yeah, I apologize if I didn't make that clear. So GridGain originally owned what is today known as Apache Ignite. So this is proprietary technology that they developed, and they donated it to the Apache Software Foundation. So on Apache, it's called Ignite. GridGain, the enterprise version, is built on Apache Ignite, the open source version, but GridGain offers a few kind of enterprise features that they didn't open source that you can't get from the open source version. So that's how they make their money. Like I said, they need to pay my salary, they need to make money somehow, okay? So that's how they do it. The standard open source model, give your software away for free, charge for a few kind of enterprise features, services, support, bug fixes, these kind of things. So there are two distinct products then, okay? So you've got the open source version, Apache Ignite, 100% open source, very capable, used in production today. You can do mission critical applications with it today if you want. And then there's the GridGain kind of enterprise version, which is built on Apache Ignite, okay? So they don't change anything for Ignite, they use that as the basis for their own enterprise version, and they add a few things on top of that, which really companies pay for to be able to use. That's the essence there.
The distribution is asynchronous?
I think it's configurable. You can have it as you want it. And then you're probably thinking about cluster-wide distribution, for example, if I want to send data. There's a variety of options available for you there as well. And then for things like disaster recovery, for example, where you might have data centers, for example, and it's active or active-passive. You can configure it in a number of different ways depending on your needs. So you might say, well, I want to have a backup, and it will just take the updates from the primary data center, and I'm not interested in sending anything back because I'm just using it as a backup. You could say synchronous, asynchronous. I mean, the way that you can configure the cluster, again, it's very, very configurable. My knowledge is still very limited, despite the fact that I've only been with the company 7 months. Still, there's an enormous amount to learn. But what I found is that at a very basic level, it's really, really simple to just set up a cluster and be able to do things. And as long as you have some familiarity with sort of Java or C# or C++, you can start building things immediately. And of course, the SQL support, great for SQL programmers as well. You can query it just like you're working with a relational database. Great. Okay, great. Let me just make sure in terms of time. So it's 11:26, okay? So I think I'm just a couple of minutes over. So now, if you want to reach me, and again, I apologize, it's not like I'm sort of running away from you, but I got a flight to catch, and I've got to get to Madrid for my next gig. So if you want to reach me, it's just first name dot last name at gridgain.com. And let me just quickly show you one more thing before we sort of wrap up. And so if you, as I said before, I'm on social media, so if you want to reach out on LinkedIn, feel free to connect. A word of warning, my surname is a typical South Asian name, this gets spelled about 8 or 9 different ways, okay? So be careful you send the invite to the right Akmal Chaudhri, not somebody else who kind of looks like their surname is the same as me. This is a big problem I have with conferences. Everybody gets my name wrong, you know? It's probably, you know, some of you might have that sort of name that the spelling is fairly unique and sometimes it goes a bit wrong, but you're very welcome to reach out and connect to me. The slides will be sent to the organizers today. Okay, I will email them and I'm sure they'll put the material up very, very soon. And in terms of the demo I showed you, again, it's freely available. Okay, just demagda at GitHub. You can download it. I think there's a POM file, okay, so you just, POM.xml file, you just load it into your IDE and it uses Maven, just builds the project for you. You don't have to do very much as long as you've configured it properly and you can just run it straight away, okay? Plenty of resources on the Apache website, okay? So ignite.apache.org is the place to go. Lots of documentation, examples, customer case studies. You can download the source if you want to have a poke around and look at the code itself, or you can get the binary distribution, and that's fine too. And it's very active, so if it's something you feel you really like to get involved with, by all means, you know, reach out and join the dev list, get involved with the project. It's pretty active and quite, so I'm actually running a slightly old version of Ignite on this laptop, but already I think the next release is out there and available. Okay, great. Well, I need to, I think, wrap up because the next speaker needs to set up and begin their presentation. So appreciate your patience and your time. Thank you very much. And I hope it's been useful for you, you know, useful to get some idea of a couple of these open source technologies that could be useful in a kind of an IoT type of environment. Okay, appreciate it. Thank you very much.